You have, this is a good review / reminder of the different types of how we solve this. So for number 1, you needed to solve by substitution. So you needed to take one of these equations, solve for a variable. This one would be the easiest. Subtract 3x on both sides. I'm just going to write it as I see it. If you switched it, that's fine. But then you're going to take that equation and put it back into the other where y is. So take that, substitute it back in, solve for x, unless you're at Miss Larson's table, you shouldn't be talking. So distribute. Combine your like terms. And solve for x by getting rid of 20. And then dividing. So find your x and then take that number and put it back in to find y. You have options. You can put it back into one of the originals or the one you solved. Does not matter. And then once you have your y value, put those together as an ordered pair. So 1, 2 would be your answer. Questions on that one? Number 2, you just needed to solve by graphing. So I'm going to do that. Start at your y-intercept. The slope is negative, so up 1, left 2 as many times as possible. Fill up your graph. With the second equation, be careful because they wrote it in the wrong order. If you want to rewrite it, you could. But your y-intercept is at positive 7. Your slope is negative. So up 1, left 1, down 1, right 1, fill up your graph. And then find where those two lines intersect. So at 4, 3 would be your answer. Remember that you can double check yourself, especially while you're practicing in Desmos or in the calculator. Questions on that one? No. The blue one? Yeah. So here, this is not in slope-intercept form, the y equals mx plus b. So we would need to either change it or just know that these are switched. So this is actually your slope, the -1, and this is actually your y-intercept. So you would start at 7 and then go up and left and down and right. We'll start 3, we may have to finish after lunch. For elimination, you're looking for common coefficients. You don't have any. You may have not done this the exact way I am about to do, and that's okay. I wanted to get rid of x's, so I multiplied the first one by 3 and the second one by 2. we'll finish that one when we get back. Alright, we're gonna quickly finish this problem so we can move on. So before lunch, we found common coefficients. We need to eliminate our x's now that they're common. So the only way to do that is to subtract. And if you're not sure, you could ask yourself, if I add these, will they cancel? If the answer to that is yes, then you would do that. But if the answer is no, then you would do the opposite. So our x's would cancel 15 minus a negative 14. That would really be adding. We would have 29y. 18 minus a negative. Again, that would really be adding. And then we could divide both sides by 29. So that y equals 2. Put 2 back into one of your equations. Doesn't matter which one. You have 4 choices. Either of the ones you changed or the original does not matter. That's y not x. So let's say I put it back into the first one. I would take it and solve. So 4x plus 10 equals 6. Solve for x. So that x becomes negative 1. So your final answer would be negative 1, 2. Do we have any questions on the elimination process? Yes. So when you are trying to make the coefficients the same, you have to think about how could I make these the same? If these were both 12, then 4 goes into 12 and 6 goes into 12, then they'd be the same. So I have to think about what could I multiply this by to get 12 and something here. Which was the 3 and the 2. Right. Hopefully this was good review on each of the different types. So that way when we get to word problems, you'll have those in your memory. Everyone should have the word problem notes in front of them. And then Matt, come back to your seat. So for each of the word problems, you will have a choice as to how you want to solve it. By graphing, by substitution, by elimination. The first 3 we do, I'm going to pick the methods. As with any word problem, you need to look and read, see what's important or not. So let's do that first. Read along with me, either on the board or on your paper.
What's up, guys? Right, and it might be really important to have a highlighter ready or something where you can underline, so that way when we start locating specific information, you know exactly what to look for and underline.
Underline or circle or highlight any of those. Right? A snack bar sells large and small nachos. Large nachos cost $5 and a small pack of nachos costs $3. In one day, the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. So, out of all of that, what do you think is important?
The number of large nachos.
You're talking about here?
Yeah.
The L equals, okay.
And the number of small nachos.
Okay, and then Mary Ellen, what were you going to say?
Large nachos cost 5 and small nachos 3.
Okay. Go ahead, Colin.
60 packs of nachos.
Any numbers you see are always important. And then for all of these problems, the very first thing we're going to do is define our variables. Last time we did word problems, there were a lot of variables you had to define because you had to know which pieces were which. For these, you just need to define two variables, the two things you don't know. Usually that is in your question. So it says, write a system to determine how many large and small packs of nachos. Those are the two things we don't know. That is going to go directly with our variables. Now, in this case, they gave us the variables. They told us what L and S represent. But if we didn't have that information, we would look here and say that L is going to represent the number of large nachos and S would represent the number of small nachos. And we would be specific. So even though they defined it for us, we're still going to write it down here so we know what those represent. So at the end, these are the two things we're looking for, L and S. Almost all of your word problems for this are going to be set up the same way. I said almost all because some are a little different, but we'll talk about that. When we talked about word problems last time, there was one specific type when you were comparing two different things where you use the ax plus by equals c. Almost all of your equations will be set up using that format. So I'm going to write it here, but change the variables a little bit. It will be set up like that. The variables might be different. The x and the y would be like our L and our S. Back when we did problems like this, I said for your A and your B, those are usually the numbers given. So here we were given 3 and 5. So those are going to go with L and S. How would we write that? Using that format, using the numbers, using the variables we have. How do you think we would write that? Marilyn? 5L plus 3S = 220. Now, we have to make another one, but before we do that, if you're not sure, because it gave you two total numbers, the 60 and the 220. If you're not sure which one goes with it, ask yourself, what are the numbers representing here? 5 and 3 are both talking about costs. So that means whatever it equals also has to talk about costs. So if you put something in that doesn't talk about that, you're going to end up with the wrong equation. So this is one of our equations because we are talking about systems. We need to have another. We cannot use these same numbers again. So once we use them once, that's done. To set up our other equation, we know the other total equals 60. And 60 is the total number of packs sold for that day. What else talks about number of packs of nachos?
Find the word packs, guys.
Number of large, or it doesn't say packs. My wording says packs, but nachos, but sure, same thing. Number of large nachos, number of small nachos. What talks about those things? Highlighted.
The small pack of nachos.
The what specifically about that?
That cost $2.
So not talking about the cost. What about the small number of nachos?
So instead of cost, what else is on here about nachos? Blank of large nachos.
the number of, and we know that both of those are already S and L. So to write our equation, we're going to add those two variables together.
Okay, so sometimes you might see number of, sometimes you might see amount of, cost of. So anything that you see blank of, it might be involved in an equation.
So with these problems, you'll either be given like numbers to fill in everything, or you won't. So like in this one, we were given the numbers to fill in everything else, but we weren't given numbers for this. So a problem like that, you won't have numbers for that second equation, but you have to know that the variables go there. Right, then once you have defined your variables, you know what you're looking for, and you set up your two equations, then you choose one of the methods and you solve by graphing, by substitution, by elimination, not all three. We're going to do this first one by graphing. So if you don't have your calculator, go grab that. Our calculators do not like other variables, it just wants x or y, so we have to change our equations to match x and y. So what I'm going to do is just make my L x and my S y, it doesn't matter which one you do, as long as you're consistent. So if you make one L in x, the other L also has to be an x. And then we're going to solve both of these equations for y. Get y completely by itself. So this second one is easy because we just have to subtract. So we would be subtracting x on both sides so that we get y by itself. But then we would also need to do the same thing to the other one. Get y by itself. Subtract 5x on both sides. And divide everything by 3. Divide 220 by 3. Tell me what that is.
73.33 rupees.
73.33. I was just looking because it's different than how we did it before. So I'm going to leave that actually as a fraction since it's a repeating decimal. Okay, then we're going to use our calculator to graph both of these. So in your calculator, once you have these written down, you're going to go into y equals and type both of these in. 60 minus x and 220 over 3 minus 5 over 3x. Alpha, y equals, will give you your fraction. Yes,
Why do you have the fractions when
alpha, y equals. And then once you have them both in there, you're going to graph. And then one or two things will happen. You'll either see them or you won't. Because these are bigger numbers, you may not see it. So we're going to zoom fit. So I went into zoom. zoom fit, which is 0.
How did you get there?
Zoom. And then scroll down to zoom fit. Yes.
What if you have it in the y equals, you press enter?
I would hit graph. And then I hit zoom. And then scroll down to zoom fit. Mine aren't crossing. So I have to rearrange this until they cross because the calculator won't work unless it sees it cross. So I'm going to go back to zoom and zoom out and just hit enter. Anyone not see them cross? Anyone else not seeing them cross? Graph. And then zoom. Go down to zoom fit. Zoom fit 0. And then you have to go another. Zoom. But I think one of your graphs are coming up. Okay, so now that I see that they're intersecting, I'm going to make the calculator find where that is because I couldn't count this. Second trace, find where they intersect. So second trace, number 5, and then enter 3 times. So second trace, intersection, enter 3 times. So this would be your intersection point. You would write this down. But I don't know which one is which. If you just write this. If you didn't start off with x and y, you need to put these back as whatever the variables were. So since x was L, L would be 20 large packs of nachos. And then y was S, so S would be 40 small packs of nachos. And that would be your answer. You would have already shown that you solved for y, so that would be part of your work. The other work, you would just say you graphed in the calculator. And that's how you got that intersection. Maybe. My thing has not been working all day. There we go. Okay. What questions do we have so far? If the graphing method is too confusing, there are 2 other methods that you can use. You don't have to graph them. It's just if you want to graph them, that would be the work you would show. Okay. Skip to example number 3. Bless you. And then take a second and read that, and then we'll talk about important things. As you read this, what did we find was important? Five pairs of earrings is important. I'm going to extend that and 2 pairs of shoes. What else is important? Say that again. Okay. This entire sentence is important. And then what else? So then we have to write and solve for the cost of both. So if we weren't given our variables, we would look at that last part, determine the cost for a pair of shoes and a pair of earrings. Those would be our variables, but we're given that, so we can already do that. So specifically, E would be the cost of earrings. S would be the cost of shoes. One of these equations are going to be set up a little differently than what we did before. So we're going to start with this section in green, highlighted in green. Each pair of shoes cost, so whatever this is talking about is representing the shoes. So I can start off S equals two more than 4 times the cost of earrings. How do we think we would write that? Aaron? 4E plus 2 or 2 plus 4E. That order does not matter. So we'd have one equation. Now we need our other one. Everything in yellow/blue is going to be used for our second one. 5 pairs of earrings and 2 pairs of shoes for $30. How would we write that? Are we okay? Okay. I don't know. How would we write that? Using that same format as before, the AX plus BY. I'm trying to not laugh, but you guys are making me laugh. Okay. If we're using the same format as before, how would we write that? Aaron, go for it. Equal what? Equals 30. So for the most part, all of our equations are going to look like that second equation set up similarly. But this one was just different because of how the wording was. if you have an equation that's already solved for a variable, which method should we use? Elimination, substitution, graphing? We could use elimination, but we'd have to solve this so that they all line up. Not substitution, elimination, or graphing. Substitution. Because we have a variable, it's solved already. So I can take this and put it in for S and then solve. So it would look like 5e plus 2 times this equation equals 30. So then we're going to take it and solve it for E and then go back and solve for S. 5e plus 8e plus 4 equals 30. Combine your like terms. Solve for E. What does E represent?
The number of the cost of earrings.
The cost of, so 2
earrings. 2 whatever.
Cost of, we would label it as dollars.
$2.
Yeah. Mm-hmm. Then we would take the 2 we found for E and go back and find S. So the equation that we used up here, I'm just going to use that same one. 4 times our E, which was 2, plus 2. So S is 10. What? $10. Okay. Anytime you get a word problem, look at your answers. Think about, does this answer make sense? If you get S equals 50, that probably doesn't make sense because you only spent $30. Something's wrong with your math. You get a negative number for cost, something is wrong, something doesn't make sense. We shouldn't be getting negatives for cost or amounts. Right, so just double check your answer, either by putting it back in, looking at it, does this answer make sense? Either of those. So just as the last time, you would define your variables, set up your equations, pick a method to solve, and solve for both variables. All right, questions on that one? We are going to go to the maze page. We're not doing all of them. We're going to do the very first one, and then if you want to use that to practice, you can. You may want to fold it so it's like this, so that you can look here but do the work somewhere on here because there's not really space for that. So take a second, read the very first one, find important information. What important information did we find there?
Which one?
The first one.
The family bought 4,000 drinks and 3 bags of popcorn. And they paid. The other family, the Hanks family, bought 5,000 drinks and 2 bags of popcorn. And they paid $23.
So with this one, it gives you 6 numbers. That means you're going to have every single variable is going to have a number as well as your total will have a number. This is only asking for one of the things, not 2 things. So when we go to solve it, we won't need to solve for both, and I'll show you which one or how to do that so it's a little easier. So the question asks, how much is a fountain drink? That tells us something we don't know. So that, by default, is going to be one of your variables. You can call it f, call it d, call it x, whatever you want. It just has to be consistent. So let's say I call that f. We don't know how much a fountain drink costs, so cost of a fountain drink. What else don't we know? Right. So you can call that p, y, whatever, it just can't be the same variable. Right. So now you have your variables. We're going to use the numbers in the problem to set up our 2 equations. How would we do that? Or what would those look like? Aaron, go ahead.
4 plus 3.
That would be the first one. And then for the second one? So once you get the hang of how to start setting these up, you'll realize that they're really all the same. You just have to put the variables and numbers together. These are going to be huge. So now we're going to use our last method, elimination. The question is asking specifically, how much is a fountain drink? So what we're going to do is get rid of the p so that we can only focus on f. So if we were to get p or get rid of p, these would need to be the same. So we're going to multiply. We can multiply by 2, and then this one by 3. So we have 8f plus 6p equals 45, I think. And then 15f plus 6p equals something. Multiply that, tell me what that is. To eliminate our p's, we would do what? Subtract, yes. So 8f minus 15f, we have negative 7f. The p's would cancel. 45 minus 71.25 would be what? It would be negative. Calculate it. Negative 26.25, and then divide. Should be 0.25. What is F? Dollars, correct, yes. So for this one, it only asks us to find one. We don't need to go back and find the cost of the popcorn. If it did ask for both, then we would have to do that. And if you look on the maze, that is one of your answer choices, so you know which direction to start going if you continue doing the maze. Okay. Most of your word problems will be set up nicely to do elimination. Some of them will be substitution, but all of them can be done all of the ways. Do we have any questions on them? There are two others I want to show you really quickly before class ends. Go to the next page. All of these problems are going to be really good elimination, but could be graphing or substitution, if you so choose. But we have to talk a little bit about what some of these things mean, just in case you're not aware. You'll see either flying or something in a boat going down a river or a stream, and you need to know the following. If something is flying with the wind is pushing the plane, so the wind speed and the plane speed are being added together. If that plane is going into the same wind, so the wind it was flying with is now going the opposite direction.
Going against it.
Right. So we would subtract those two. And again, we'll do a couple of these so you see what I'm talking about. Talking about wind, they may say tailwind instead. So think about that as the wind is pushing the tail of the plane forward. So it's helping it, it's adding to it. And then again, if it goes back into the same wind, it's going in the opposite direction. With the river, if it's going down the river, assuming the current is going that way, it's going faster that way, going down faster. But then when it returns going up the river, it's going against the river, so the speed is slower. You're subtracting. Down, up, down, up. And then same thing with the current, so it's just talking about with the river, the speed of the river. With it, it would be pushing it, it would be helping it along, moving it faster. Against it would be going in the opposite direction, so it'd be going slower, so you'd be subtracting. So you'll need to know the difference between those things when you see any of these problems. But for number 1, we are flying with the wind. The plane went 369 miles per hour. Flying into the same wind, the plane only went 325 miles per hour. We need to find the speed of the plane and the speed of the wind. So the two things we don't know, it told us, the speed of the plane and the speed of the wind. Those are going to be your two variables, whatever you want them to be called. So I'm just going to say plane speed and wind speed are the two things we don't know. The two numbers they give you are going to be your totals. So if a plane is flying with the wind, are we adding or subtracting those together? Adding. So this would be P plus W. Flying into the same wind, how would we write that? P minus W. And if you're not sure which one you're subtracting, ask yourself, is the plane helping the wind or is the wind helping the plane? The wind is helping the plane, so that means we're subtracting the wind speed, not the plane speed. So all of these equations are going to be set up similarly. You just have to know how to set them up. And then, like I said, these are good elimination problems. So we can get rid of P or W first, does not matter. Which one do we want to get rid of first? P, okay. So if we're getting rid of P, what operation would we use to eliminate that? Correct. So the P's would cancel. W minus negative W would really be plus. 369 minus 325 would be 44. And then divide. And then your label would be whatever it says. So here, miles per hour, that's what you would use. Use that W to find P. Doesn't matter which equation you put it into. Solve for P. So these numbers, because of the equations, you're not like multiplying other things, it's really simple to go back and double check. 347 plus 22 gives us 369. 347 minus 22 gives us 325. So that's a really good, quick way to check yourself. Did you do this correctly? Also, look back at your answers just like before. Make sure it makes sense. In theory, if nothing's going on in the world, like there aren't any tornadoes or anything like that, plane speed is supposed to be higher than the wind speed. If your wind speed is higher, something's probably wrong. In general and in your problem. All right, questions on that one? So for number 2, same thing, but now we're dealing with a boat. Going down the river, the boat went 13 kilometers per hour. Going up the river, it only went 3 kilometers per hour. We need to find the speed of the current, so that's like the river, or how fast the boat would go if there were no current. So don't be tricked by the wording of these questions. The speed of the current, so let's call that C. We're looking for how fast the current is going or how fast the river is going. And then the second question is really asking how fast is the boat going, because the current is no longer helping them. So you're looking for the boat's speed. You're not looking for the current at a standstill, because we don't need to know that. You're looking for the boat's speed. How would we set up these two equations? very similar to the last ones we did. What would the equation for going down the river be?
So we've got
Not for this one. Okay. We're adding C plus B equals 13. Because the river is helping it, it's pushing it along. What about the other one? B minus C. Be careful with your subtraction because the order matters. If you want them to line up, you can switch your B and C for the first one. So then again, we can solve by elimination, or you can choose one of the other ones. Let's say we get rid of C. What operation would we use to get rid of C? Because if I subtracted here, I'd have 1 plus a negative 1. I'm sorry, 1 minus a negative 1, which would make that a plus. But if I add it, 1 plus a negative 1, that would cancel. We have 2b equals 16. So that b equals 8 kilometers per hour. And then we could go back and find c. And then again, these numbers are small enough that you could put it back. 5 plus 8 is 13. 8 minus 5 is 30. Yes.
Wait, how do you know when to subtract or add the equation?
So if you are getting rid of your C's and you're not sure, I would double check in your calculator. If I did 1 minus a negative 1, is that going to eliminate it? No. But if I do the opposite, the 1 plus the negative 1, that would. So at any point, if you're not sure, double check in your calculator. Yes. Yeah, go ahead and make the pass. Great. We don't have a whole lot of time left, but using the rest of class, you have a bunch of problems in this, a bunch of problems in the review that's also sitting on your desk, the 2 Khan Academies that are due on Friday. Use any of those for practice for the rest of class. Your quiz is next class. So bring any questions you have on the review to next class, and then we'll go through those.